we're gonna do something called basic percent problems. But I just want to warn you that the word basic is misleading. It's not that basic. I mean, it will be basic at first, but it's not gonna be. There are gonna be tricky things. There are a gazillion different ways of doing basic percent problems. If you already have a way that produces quick, correct results and you feel you understand it, keep it. I'm not here to take it away from you. But if you don't, well, this is what I offer. And my take on mathematics is that just very few things are there to be memorized, and then most things, if you understand, you can figure it out on the spot. So some people think that math is heavy on memorization. I think that's only true when it's done badly. I think the thing that got me into math that I hate memorizing. So that's kind of the philosophy behind the things that I do, that it's very little memorization, but then you have to understand and practice, of course. So before we start with percent problems, let's just do something called basic fraction problems. So let's find, this is nothing new here. Let's find 3/4 of, I don't know, 80. And by us, I mean you.
60?
Yes, thank you. So we're gonna make a statement. 3/4 of 60, oh, of 80 is 60. Great. 3/4 of 80 is 60. And I've seen it in a book, but it's hideous. We're gonna do something hideous. There are 3 characters in this little statement, and we're gonna give them names. We're gonna call this the fraction, and it's gonna be very recognizable. It's either a fraction or a standardized fraction, namely a percent. We're gonna call it the fraction. And I'm gonna denote it with a capital F for fraction. Now, many people call this number the base. It's the thing of which we're taking, the takes a portion of something, that of thing. We're gonna call it the of number. I know it's terrible, but I saw it in a math textbook, in a good one actually. So this is gonna be the of number. The word of is nearly always immediately before it. So this is gonna be called the of number. And this is gonna be called the is number. This is sort of the part that we compute. This is gonna be the is number. And basically, we're gonna apply equations to turn this scenario into 3 different types of problems. Basically, I can give you any 2 withholding and asking for the third one. So what we just did when I said find 3/4 of 80 is when the fraction and the of number is given and the is number is asked. We're gonna call that type 1. It's the most straightforward way. In fact, we can sort of develop a formula. That is, if you recall, we get the same 60 if you just multiply the 2, right? 3/4 times 80, there is a cancellation, and that's 3 times 20, that's 60. So basically, the big one formula, the one formula we're gonna memorize is that the is number is the fraction number times the of number. And there is not gonna have to do with type 1 is not new. The new is gonna be type 2 and type 3 when other things are given. So type 2 is gonna be something like 18 is what fraction of 48, or 35 is what percent of 140, right? This is type 2. So whenever you see a basic fraction or basic percent problem that's not type 1, my recommendation is the following. 2 out of the 3 things are given. Figure out which 2 are given, call the third one x, and state this formula, and then solve the ensuing equation. So instead of memorizing 3 different formulas, we're just going to use this formula once and solve for different parts of it, which is very, very typical to mathematics. So in this case, is fraction times of is the formula we're going to use. And I usually try to find, so 18 is what fraction of 48 is fraction times of. Now, the beauty about 3 things, if you can figure out 2, the third one goes by elimination, right? So what is missing, or can you identify what are these 2 things given? Who is the is number, who is the fraction, who is the of number? Whatever they are withholding and asking for, we're going to call that x. So can you sort out this little casting? Who's going to play is, who's going to play the fraction, who's going to play of?
Is 18.
Very good.
Fraction is x.
Very good.
And then 48 is off.
Perfect. And after a while, you're not going to need to write this table. But at first, it's not a bad idea. And now we're just going to state this. Is fraction times of. And now the word problem is over. And we're looking at the one-step equation, right? Solve for x. X is 18 over 48. And all we got to do is reduce this fraction. I definitely see a 6. So if we divide upstairs by 6, we get 3. If we divide downstairs by 6, we get 8. And I think this is it. So the answer is 3/8. And checking is always type 1. So checking is always type 1. So to check, take 3/8 of 48, and it better be 18. Very straightforward. It's just some people make people memorize 3 procedures. I just say 1 formula and you know how to solve equations. Now, after a while, you're not going to need the table. It's going to organically speed up to something like, once upon a time, there was 48, and when we took x fraction of it, we got 18. So you're going to be able to come up with this without the little table, but don't rush it. Have that little table first. Okay. And there is going to be an extra little twist, which I hope I manage the numbers right, when it's a basic percent problem type 2. I knew I was forgetting something. So if we're asked 35 is what percent of 140, then basically it's the same problem, but at the end, instead of a reduced fraction, we should make sure we land on a denominator of 100. And for that, the numbers should be friendly. We'll see. So again, is, you see now the word is not before, but right after. So it's still close enough. The is number is 35. The fraction is asked, what percent what fraction, and the off number is 140, and the formula is always is fraction times of. So 35 is x times 140. And then now so the problem is so far identical, but now we're going for not a reduced fraction, but we want a denominator of 100. Well, you have to bring it in a percent form. So someone is sending me an almost perfect answer. So the problem is we're not lucky with the denominator. The denominator should be a divisor of 100, if not 100 right away. So let's just simplify it, not all the way, but do you see a 7? There is a 7 there, right? And if we simplify, if we get rid of the 7, then things turn out much better. This is 5 times 7, and this is 20 times 7, right? We can actually check with the calculator, but the calculator is going to get rid of more. There is a 5 left there, right? But we don't need to get rid of the 5. In fact, we're going to need to go towards percent, but let me just pretend that it's a fraction. And we want to simplify it. And 1 over 4 and 5 over 20, that's an easier check. We can also enter 5 over 20. Now, we can further simplify, but that's not what we need to do. We need to rewrite this with a denominator of 100. And that means multiply upstairs and downstairs by the same number. That number was 5. 5 times 5 is 25, so it's 25%. Okay, we're going to go back to this conversion because if you enter this, well, I guess we should talk about it now. So we're missing this decimal class. If you type in 35 divided by 140 as a division, you get 0.25. I don't know whether you recognize that's a quarter, but 0.25 is a decimal, and if you want to rewrite it as a percent, that's a fraction with a denominator of 100. So let's just break down into smaller projects. Let's just make it as a fraction first. And that's a very useful denominator 1, because now we just need to multiply upstairs and downstairs by 100, right? Why 100? We want percents, and then decimals are nice with respect to 10 powers. It's just a matter of moving the decimal, right? 0.25 times 100 is going to be 25. In fact, might as well, let's do this now. If you have a really I got lucky because I managed the numbers to make it friendly, but that's not always going to be the case. For example, 1/3 is a terrible fraction. 1/3 as a percent. Well, 3 is not a divide. We cannot multiply upstairs and downstairs of this to go to 100 because 3 is not a divisor of 100. So then it's not a bad idea to go to a decimal. 1 over 3 is 0.33333. And then go from there, grow a 1. And then multiply upstairs and downstairs by 100. So as it turns out, 1/3 is 33.333%. Right? And then there are worse fractions, like 1 over 7 is one of the worst. So if we need to write 1 over 7 as a fraction, 1 over 7 is a fraction. As a percent, the trouble is that 7 is not a divisor of 100. Just multiplying upstairs and downstairs by a suitable number will not take us to 100. So then go to a decimal. So first go to decimal. So 1 over 7. And this really equal sign means approximately equal. It's gonna be rounded. This is kind of an what is something you always hate and you wrote about? Peekaboo? Peekaboo? No, that is a word I'm looking for. So it's something that algebraists try to avoid rounding, losing precision, which is why 1/7 is much better as a fraction because it's a terrible decimal, right? 0.142857. Okay. And then we can grow a 1. And now 1 is a divisor of 100. We just multiply upstairs and downstairs by 100. And when we do that, the denominator is what we want, and the numerator is, that's just a matter of moving the decimal point. If we multiply this by 100, you will see that it's just the decimal point was moved. Each decimal place was promoted when we multiplied it by 100. So we get 14.2857 over 100, or 14.2857%. So 1/7 is about 15%. It's a little bit less than 15%. But I think we're using percent so often that we kind of have a feel for what's that. Okay, so that's the only complication, but you're not going to see it at first, I guess. We have very little time left from the semester. So that's type 2 with that occasional complication. Any questions about type 2? All right, let me give you 2 type 2 with percentages, one nice, one not nice, okay? So let's say 30 is what percent of sorry, let me get a nicer number. 12 is what percent of 27? Wait, sorry, I'm terrible. But let's do 60. And 12 is what percent? Of 96. Wow, the first one was very quick. You guys did the whole dance and song? Or you have your own technique? But that's okay. Fast is never a problem. Well, fast and correct. So for the first one, the is fraction times of is the formula we're going to use. And twelve is the is number, the fraction is as, and the of number is 60. So this formula becomes 12 equals x times 60. Solve for x. X is 12 over 60, which if we get rid of the, so yeah, it simplifies to 1/5, but that's not the question. If I say what fraction, the answer is 1/5, right? But the question was what percent, so let's just get rid of the 6, or even the 3. I'm gonna go with 6. 2 out of 10, and that's 20/100, or 20%. And then you can make those connections that are hardwired in your brain, like 20% is 1/5. Those are useful. So that's the first one. And the second one, where the numbers may not be as nice, but I see they're fairly nice, is 12. The fraction is as, but the of number is 96. So the formula is equals fraction times of. My recommendation is until you get it really, really memorized, just state it every time you use it. 12 equals x times 96. So x is 12 over 96, which is less lucky. It's even after cancellation. I think 96 is 6 times 12, but we can just cheat with the calculator and say 12 fraction bar 96. Yeah, oh, 1 over 8. So I was wrong. It's 1 over 8, and the problem is that 8 is not really a divisor of 100, right? So then my recommendation is go to decimal and then scale up to 1 is a lovely denominator. So 1 over 8 is 0.125. Zero 0.125 is 0.125 over 1, and then we multiply upstairs and downstairs by 100, and we get 12.5%. Any questions about type 2? All right. So type 3 is, I think, the most exciting. I left a little space for it. Okay. Oh, I'll start with the fraction and then with percents, but the complications with percents you have seen in type 2. Type 3 is just more interesting. So type 3 is 3/7 of a number is 6. Find this number. Or 15% of a number is 75. Find this number. Or 3/7 of what number is 6? 15% of what number is 75? These are the two ways you're going to see it phrased. So that's when the is and the fraction are given and the of number or the base is withheld. And this is where we had to wait until division of fractions. So type 3, 3/7 of a number is 6. Find this number. So is fraction times of. Who goes where? Who is who in this game?
Is 6. 3/7 is fraction.
Yeah. And then of is x. Usually two are easily identifiable, especially the fraction, right? So we rewrite this. We're gonna say 6 is 3/7 times x. And eventually you're not gonna need this table, but you're gonna say something like this. Once upon a time there was a number x, and when we took its 3/7, we got 6. I have no idea, you're way ahead of me. It sounds right, but I'm not sure. So now you see we have a one-step equation, but with fractions. So
we're just finding the number, right? Not the percentage.
We're
just finding the number, not the percentage yet.
You're
Are we
just finding the what?
Are we just finding the number and not the percentage?
The percent, so this is a basic fraction problem. I gave two examples. In the second one, the fraction given is a percent. So the percent was given, but 3/7 is not something you want to express as a percent. So no, we're just finding the off number.
Okay, thank you.
And I think you have the correct answer already. So don't expect much beyond that. You're ahead of the game. Don't expect to be surprised then. So the way I see it, again, there is a gazillion different teachers with different ways. The way I see it, this equation is not really different from 2x = 10. What would you do to solve 2x = 10? I'm sorry, 2x = 10. What would you solve what would you do to solve this equation?
Divide 2.
Right. So here I would say, well, what is multiplying both sides? What is multiplying x is 3/7. So I want to divide by that. And then 6 divided by 3/7 is x. So basically just have a big picture attitude. And yeah, the steps are going to be a little bit more worky, but you don't need a new principle or a new philosophy to solve a one-step equation. It's just performing this division is going to take more work than 10 divided by 2 is 5. But just so you know, there is a little glitch. We talked about this in maybe a first week, that this here is meaningless because 20 divided by 4/2 is completely different from 20/4 divided by 2. Right? So make sure that you're clear about, you shouldn't have the same size of fraction bars when you have fraction division. You should have a distinctly, this has to do with division not being associative. It's another terrible property of division. But then to divide is to multiply by the reciprocal. If you need a 1, grow 1, see growing a 1 is, hey, I think, oh, I multiplied by the number. I'm gonna get worse every day. So to divide is to multiply by the reciprocal, and then it's 14, not 21. But I totally believed you when you said 14. I mean 21. So we should check. Check is always type 1. We take 3/7 of 14 should be 6. And it looks pretty clear. Once every solved problem seems easy, right? It is, right? Because you cancel out 3 times 2 is 6. So it's 14. That's type 3. And then type 3 with percent is our example was 15% of a number is 75. Find this number. And you know, sometimes it's gonna fool you and double, but let your imagination, let your instinct loose. 15% is like 10%. That's like 1/10. So the original number is gonna be significantly bigger than 15 or even 75, right? That's kind of good to measure your. We will actually check, but to kind of sort of assess the question, even walking into it, use your quantitative instincts. You're gonna get them sharper that way. So this should be 15% of 100 is 15, right? So this is gonna be a larger number. All right, so is fraction times of, is fraction times of, who is who? Who is who in this little table?
Is 75. 15% is off.
15/100.
Is the what?
The
Oh.
frac,
Or
It's the
fraction.
fraction. I understand that the of is right, but it's with the of a number. Or 15% of what number? So you're right, but this is the fraction. So, and you have three forms. You can use it as reduced fraction and start considering decimals. It depends on how pleasant the numbers are, but the least amount of button punching is 15 divided by 100. Percents are really well aligned with 10 powers, and and decimals are basically just fractions with 10 powers in the denominator only. So 0.15 is going to be a very frequently used, yeah. I'm going to use 15% now, but keep in mind that 0.15 is the least amount of button punching to enter it. And then the of number is x. So is fraction times of, and 75 equals, I'm going to use 15 over 100 times x. And then again, it is a one-step equation where the one step is, well, x was multiplied by a number we want to undo. So we divide both sides by whatever is multiplying x. So x is 75 divided by 15 over 100, which is 75 over 1 times 100 over 15. 75, I believe that's 5 times 15. 75 divided by 15 is 5. So 500. But you can just do 75 times 100 divided by 15. If you get something yucky, that's when you have to stop and see what fractions cannot be gotten rid of. But the answer is 500, and checking is always type 1. 15% of 500 should be 75. So it looks really, really easy. But again, the word basic should not confuse you. Let me get you messed up a little bit. Well, first of all, you're going to have to determine which type it is. And basically, with type 1, you don't really need an equation. I mean, the equation is of the form of x is this times that. But with the other two, you're going to solve a one-step equation. But there are tricky things. Well, here is tricky thing number 1. Let's see. 45 is what percent of 18? You see something strange going on here?
so in this case, would 45 be the percent?
No, the percent is x. This is type 2. So we're done with the individual examples, and I'm going to give you, I'm not telling you what type. Well, I just told you, but we're done with the basic prototypes of type 1, type 2, type 3. Now you're going to see complications. And the complication here is that 45, shouldn't it be the other way around? I mean, it sounds easier if we say 18 is what percent of 45, right? 45 is too big for this row. Right? This sounds more reasonable. This sounds a little weird, doesn't it? Because 45 seems to be too big, or is it? Oh, this is sweet. Okay, so what's strange here? 45, the is number is bigger than 18. So let's just solve first the kind of the one that's reasonable. 18 is what percent of 45? Oh, also do what fraction? So there is a conversion there. You got 3 minutes. So this is type 2. Just so you know, we should, again, just guesstimate. 18 is close to half of 45, right? It's less than. Half of 45 is what, 22 and a half. So our answer should be somewhere between, I don't know, 30 and 50%, like 40%. Is that really what it is? That way, if you're off by a decimal, like 4%, you will have a red flag. So is fraction times of, and again, 18 is the is, 45 is the of, and the what fraction, what percent are asked. So is fraction times of. So 18 is x times 45, and now x is 18 over 45, and we are asked for both forms. So as a simplified fraction, I believe there is a 9 we can get rid of, upstairs and downstairs, right? It's 2 over 5, which is actually easy to go to a fraction, a percent, because we just multiply upstairs and downstairs by 20. And we get 40%. So the answer is 40%. So 2 over 5 or 40%. Okay. But you will be asked things like 45 is what percent of 18? I've turned things around. Very good. So excellent. There are percentages more than 100%, especially in the age of inflation, in the age of budgets, in the age of exploding population or whatever. You can easily have things like 300% increase. What, tuition rates increase like what, 6,000% during the last 60 years? So it's quite easy to go beyond 100%. You just have to recognize it and not freak out and say 25%, which is an error I often see. So if your is number is bigger than the base or the of number, the percentage is above 100%, and don't panic. Keep your cool. Otherwise, it's all the same. So it's more like an emotional issue than a mathematical one. Is fraction times of. So 45 is the is, 18 is the of, and x is what we're asking. We're going to ask fraction as well. So is fraction times of. 45 is a fraction of 18. So x is 45 over 18, which is 5 over 2. So yeah, if you swap the is and the of number in type 2, you're just going to get the reciprocal, right? 2 over 5 or 5 over 2. But 5 over 2 as a percent, and I think you should especially get used to looking at decimals and interpreting as 5 divided by 2 is a nice decimal. 2.5 is 250%. I think so. 5 over 2, and then we multiply upstairs and downstairs by 50. we have 250 over 100, which is 250%. And then we can check. 100% is the number itself. That's 1. 200%, that means twice. So 18 twice is 36. So it's even more than 200%. So 2.5, if you accidentally land on a decimal, then you just grow a 1, and then you multiply upstairs and downstairs by 100. Okay, all right. So now for the tricky part. So we have an item and the price went up from $18 to $45. Now, what percent of an increase is this? What percent of an increase is this? And the problem with this question is not math, it's a convention. Well, we know that, oh, wait, this is not what I should have done, but that's all right. So here is the problem. Let me ask you two type 2 questions. 45 minus 18 is 27. So 27 is what percent of 18? 27 is what percent of 45? These are two different questions, and we can compute them both, right? Actually, but the question is, and this is something not math, it's a matter of convention. People agreed before us. What do we do when we're asked to compute this increase from 18 to 45? What percent of an increase is this? What do we compare that change? So just so you know, the change between 18 and 45, actually, let me make the numbers easier. I'm sorry. Let's just double it to 36. What percent of an increase is this? The change is 18. It's what percent of the original, or 18 is what percent of the, I don't like this one either, of the new one, right? Now, there is an easy answer to this, 100% and 50%. Can you see 18 equals to 18? So when someone doubles the price, is that a 50% increase or a 100% increase? We could go either way. You guys are right. So the convention is we always go, which was the earlier condition? The earlier condition is the thing we compare to. So this is the correct answer. I have seen jokes when, you know, they were playing with numbers, and I always like that when something went up, a price doubled, and then they said, oh, what are you talking about? That's a 50% increase after all. And then they made a joke that the change is 50% of the new price. So indeed, the convention is we always compare change to the earlier condition, starting condition. So the funny thing is, if we go from 18 to 36, that is 100% increase. doubling. But then when we go back, suppose it's a big disaster, no one buys our lovely product that looks like it's not lovely enough for a doubling price, so we go back. But I'm not going to say back. I'm just say go from 36 to 18. That's a 50% decrease. Right? So that's already a little weird that for a full circle, we increase 100% and then we decrease 50%. And things will not, tricky. These things are tricky. Basically, this is, well, I'm not even gonna. And then things are even worse. I think you have seen already compound interest, that when what you take when we had compound interest, we got 3% of our money, and then the next year it was still 3%, but of a bigger base. So here is another tricky thing, and this is kind of this is going to be a little journey. So in percent world, 10 plus 20 is more than 30. And what I mean that 10% increase and then a 20% increase of a bigger quantity is going as a single change will be more than 30%. So this is what we're gonna do. Let's start with a lovely, I don't know, 100 sounds like a very good thing, but I like it to be more divisible. Let's start with 500. So start with 5. So here is the plan. We're gonna start with 500. Just it turns out the quantity we start with doesn't matter. Increase it by 10%. Get a number A, get a number, I don't know, M. Then increase, not 500, increase M by 20%, get P, and these are all type 1, and then P minus 500 is what percent of 500. So we're gonna just follow the numbers. We're gonna take 500, increase it by 10%. Then that new quantity, we're gonna increase it by 20%. And then the number that we get, we're gonna compare that change from 500 and express it as a percent. This is gonna be type 1, type 1, type 2. This is the change. The change is what percent of the original, right? And the whole thing is tricky because that 20% is not going to be 20% of 500. It's going to be 20% of a higher number. All right, are we ready? Let's do it. Find M. So increase 500 by 10%. What is 500 increased by 10%? No, that's, so you're right about the 50, but if someone raises your salary from 500 to 50, you're gonna be troubled about that, right? So 50 is the change. So it's 500 plus 50. So it's 550, right? Okay, good. Now, increase 550 by 20%. $660? That sounds, oh wait. You're right. I'm getting 660 as well, right? Oh, by the way, here is what I did. Is this some sort of a cheating? Or this is going to be a whole other conversation, is that, well, let's just worry about one thing at a time, but there are going to be sweet shortcuts. We get 660. So the change from 500 to 660 is 160. So now the question is 160 is what percent of 500? So in these consecutive changes could be expressed as a single change, but it's going to be more than 30%. So 160 is what percent of 50 or 500?
Shit, my brain is working.
That's good. Focus. That's good.
Okay, hold on. I think
Mhm.
next until I'm muting here. I was like, he speaks. I'm getting 32 as well. So in percent world, 10 plus 20 is 32. Because that 20% of that 10%, I think that's the extra 2%, right? So this is a type 2 thing. We're gonna solve it. Is fraction times of is 160. The fraction is what we want to know, and the of number is 500. So is fraction times of, so x is 160 divided by 500, which all we gotta do is get rid of that 5. So that's 32 over 100, and that's 32%. So in percent world, 10 plus 20 is 32. But you see, by which I mean a 10% increase, and then a 20% increase. That's why compound, when increase is the same as one swooping 32% increase. These things get tricky. And again, I say that a what's that extra 2% is that 20% of that 10%. That extra 10%, 20% of that, it's 1/5 of 10%, that's 2%. So that's why. And then there is a whole other thread, which I would like to point out. Let's do another question. increase increase 80 by sorry, not 80. $250 by 15%. No, I'm sorry. Let's just do sorry. Let's do 400. This is type 1, right? Just compute 15% of 400 and add. But now I'm going to ask you for another type 1. Compute 115% of 400.
$460.
Yes, so this is a really dirty little shortcut is that, and I couldn't have planned it better because it has to do with factoring. For that these two are the same, right? I hope you were answering the second one. So yeah, they should all give you the same thing because check this out. So we want to increase 400 by 15%. That's 400 plus 15% of 400, right? And this is really a multiplication. And then that 400 is the same as 100% of 400 plus 15% of 400. And that's the same as 100% plus 15% of the same 400. Because this is a multiplication, right? And that's 115% of 400. So the quickest way to perform this is like this. We would say, well, 15%. If something starts with 100% and we increase it by an extra 15%, that's 115%. So we're going to compute 115% of 400. That as a decimal is just going to be 1.15. You can first make sure 115 divided by 100. And then you multiply that by 400. It's very little button punching. Isn't that sweet? So that's why that's a very important connection that is made here. That's why if we go back to our little example of 2 consecutive changes, so the quickest way to increase 500 by 10% is this. Because take 500, that's 100% of itself. Add 10%, now it's 110%. And 110%, you're not going to need to punch this in a lot. This is 110% as a decimal. And then we want to increase this number by another 20%. That means we want it to grow up from 100 to 100 plus an extra 20. That's 120%, right? 120% as a decimal is 1.2. So if I just hit it by 1.2, See, there are just really, really quick ways to get there. And this is not trivial because percentages are multiplicative things, but we use it with addition, and that causes all kinds of weird stuff. Like a full circle is 100% increase, and then backwards it's a 50% decrease. That's kind of freaky. Oh, okay. All right. So I know I dumped a lot on you, but we'll stop. I went further than I thought I would. You guys are understanding even this last weird stuff here? Why these two are the same? You guys are... All right, okay. And then we can do the trick with decrease. So for example, let's decrease. This is not type 3, I'm just numbering them. I shouldn't even do it. Decrease, I don't know, 400 word. 400 by 30%. Compute. Now, what percentage do we get left if we lose 30%? Awesome. So if we lose 30%, what's left?
Isn't it 280?
No, 180?
280.
Oh, I have no idea. I'm waiting. You're probably right. And here is the cheaty way. If you lose 30%, what you're left with is 70%. 70% as a decimal is 0.7 times 400. You said 280? You're correct. See, this connection, not trivial at all. These are multiplicative things that we add and subtract. These are subtle things, and yet they're important. This is a very important topic. I think. Okay, I'm gonna edit this out, but once I met up with an old student of mine. She took the next class, intermediate algebra. She took that with me, and then years later, she took business calculus with me. And then further years later, I don't know why and how, but we went out to eat, and she insisted to pay for my lunch, which was nice, but she made me compute a tip, 20% tip. She made me compute it. After she took intermediate algebra, I got so mad. I got so angry that I basically don't let any class out of my hands without knowing percentages. I mean, 20%, what is 20% of $80? That's not how much the food was, but maybe it was $30, I think. What's 20% of $30? Come on, do it in your head. What's 10%? So 20% of $30. Now this is practice to do it in your head. What's 10% of $30? Oh, there's some generous tipsters here. So 10% is 1/10. You should 50% is 1/2, right? And you can do the math, 50 over 100, simplify 1/2. 10% is 1/10, which if the thing ends in a 0, just lap off that 0. So 10% of 3, that's okay. Tipping is, yeah, always tip well. And I have something to say about that. That's not math, but let's finish the math. 10% is 1/10. If there is a 0 at the end, lap off that 0, and that's 10%, and then double it. Yeah, that's 6. So she made me compute like 20% of 30. I almost lost it. By the way, I just want to say something about tipping. I disagree with that it should always be a fixed percent. If you go to a cheap place, those people work just as hard as people at an expensive place. So if you're in a cheaper place, feel free to tip more than, your fixed percentage amount. Those small little things go far in other people's life. Thank you. All right, I thought I will not have to edit this video, but I don't think I have the right to tell you to be a generous tipster. But I have the right to get mad if you come back to me years later with a degree and you don't know how to compute 20% of 30. So ever since, I'm doing percents no matter what the class is. I learned something in that lunch. Okay, any questions? Oh, yeah, so, and by the way, that's 6. Okay. All right, so we finished that one. We went further than I thought we would.